Hello everybody, welcome to Geometry Algebra 2 Block. We're starting chapter 10 today, which is all about circles. I'm going to do a video that's got some circle vocabulary in it, and then there's two key ideas for today. The two key ideas that you want to pay particular attention to are central angles and inscribed angles. You're already somewhat familiar with central angles, so let's start with those. We've done central angles kind of throughout the school year, and we know that when we've got central angles, those angles are going to add up to be 360 degrees. So what we're going to do is see if we can calculate how big X, Y, and Z are. I'm going to give you a moment to see if you can think about how to do those. And hopefully you can see that the key idea here is that you want to keep in mind that those angles are going to add up to be 360. So in the regular pentagon, you've got all 5 angles that are the same size. And so you can do 360 divided by 5 to get your answer of 72. If you look at the circle in the middle, you know that all the way around the circle is going to be 360 at the center. This time you've got this 90-degree angle that's not included as part of Y. So angle Y is everything around this part of the circle. So what you'd want to do is 360 minus 90. For that one, you'd get 270. And then for the final one, if you take a look at what kind of shape you've got, if you draw in all of your angles and you count them up, you've got 8. So if you do 360 and divide by 8, you get 45, which is your answer for the last one. Okay, so now we're going to talk about some circle vocabulary. So there's a few different vocabulary terms that you need to know throughout this unit. Some you might be familiar with, some you might not. The first one is one that you should be familiar with. It's a radius. So a radius is a segment that goes from the center of the circle to the edge of the circle. So in this picture, B is at the center of the circle. If you go from the center out to the edge, that's your radius. And you probably know this one as well. So this is a diameter. I can tell it's a diameter because, again, it goes through the center of the circle, but it goes out to both edges of the circle. So it's the full way across the center of the circle. That's a diameter. This next one you may or may not know. So now we're working on the edge of the circle. You've got these arcs that go around the circle, and a small arc like this is called a minor arc. A minor arc is when you go less than 180 degrees. So any arc on the edge of the circle that's less than halfway around the circle is called a minor arc. An arc like this, on the other hand, that goes more than halfway around the circle is called a major arc. So a major arc is going to be an arc that's greater than 180 degrees. I do want to point out this arc symbol right here. You can see that above these letters A, B, C, we've got this arc symbol to represent that it's an arc as opposed to an angle or a line segment. If you see 3 letters like this, you're going to start at the first one. So start at A, go around till you get to B, and then end at C. Oftentimes when you've got a major arc, you're going to use 3 letters to show you which way to go around the arc so that you know what direction to go and how big your arc is from the start at A all the way through B and then ending at C. The next vocabulary term is one that we did in our warm-up. So this is an example of a central angle. I can tell it's a central angle because it's right at the center of the circle. So I've got my angle B here. We've got B at the center of the circle, central angle, center of the circle. This is an example of a central angle that's 110 degrees, and one of the things that you need to know for today is that if you know how big your central angle is, the arc that goes with it is the exact same size. So the arc from A to C, if you follow this around here from A to C, that arc is the exact same size as the central angle. So if your central angle is 110, that means that your arc is also 110. I'm going to show you an example of a problem where you might have to use this idea. So here we've got a regular pentagon. So we know that all of the sides of the pentagon are the same size. We know that all of the angles in the pentagon are the same size. And we're going to see if we can calculate how big angle EFA is. This is exactly like what we did in your warm-up today, where to figure out this angle, we're just going to do 360 divide by 5 for a pentagon, and so we get 72. In fact, all of those angles around the center of the circle would be 72. They'd all be the exact same size. So if next I wanted to figure out how big angle BFD is, that means that I'm going to take 2 of these 72s and combine them together. So from B to F to D, it's a combination of these two 72s. If you add 72 and 72 together, you get 144. I might also ask you on a problem like this to calculate an arc. So this one's arc ACD. So if I start at A, I go around to C, and then end last at D, what I would want to do is figure out what that would combined up to be. If you remember, all of these central angles are the exact same amount as their arcs. So like from A to B is 72 degrees, from B to C is 72 degrees, and then from C to D is 72 degrees. If you combined all 3 of those together, 72 plus 72 plus 72, you get 216 total for that arc. The second key idea for today is an angle that looks like this. So this is an example of something called an inscribed angle. An inscribed angle has its vertex at the edge of the circle. So the vertex is on the edge of the circle. So A is on the edge as opposed to being at the center. That's an example of an inscribed angle. When you have an inscribed angle, the relationship between the angle and the arc is a little bit different than a central angle. We're going to try to figure out how big this arc is right here. The trick is to just take 30 and to double it, and you figure out how big your arc is. So an inscribed angle is always half the size of the arc that goes with it. So the arc is the bigger one, the angle is the smaller one. So let's build on this problem a little bit. If we know that that arc is going to be 60 degrees, let's see if we can figure out how big angle DAC would be. So if I want to try and see if I can figure out how big angle DAC would be, that would be this angle right here that I've got in green. Notice that I added the 110 degree arc onto the picture here to try to help us calculate this. If I know that that arc from D to C is 110, if I'm going to try to figure out how big the angle is, I'm just going to do half of it. So if I do 110 and I divide it by 2, I get 55 degrees for that angle. Now let's see if we can figure out how big arc AD is. So we're going to see if we can figure out how big arc AD is. That means we're going to try and do this green piece over here. So we're trying to figure out this arc from A to D. Notice that I said that AC is a diameter of the circle, so this dark green line is a diameter of the circle. One of the key ideas for circles is that all the way around is 360. So if you just have a diameter, that means that that's going to be 180 degrees. The way to figure this out is to take 180 and to subtract 110, and you get 70 left for the rest of that arc. So all the way from A all the way around to C is 180 total. So if you do 180 and you subtract this 110, you've got 70 left. Okay, the last thing we're going to try to figure out on this picture is how big arc AB is. So now we're going to see if we can figure out how big the arc is from A to to B. So now I've got this in this lime green color, how big it is from A to B. Again, halfway around a circle is going to be 180. So all the way from A to C is going to be 180. The way that you could calculate how big it is from A to B is to take 180, subtract 60, and you would get 120 degrees for angle A, or for arc AB. Okay, here are 3 examples of circles that have central angles and inscribed angles, and we're going to see if we can figure out how big the matching angles and arcs are. This 50-degree angle right here is an example of a central angle. It's at the center of the circle, which means that the arc is the exact same size, so it's also 50 degrees. The 47-degree angle is also a central angle, which means that the arc is going to be the exact same size, so C is also 47 degrees. The 35-degree angle is not a central angle. It's not at the center of the circle. Instead, it goes all the way to the edge of the circle. That's called an inscribed angle. And when you have an inscribed angle, to figure out the arc, you double it. So if you double 35, you get 70. And then for our final one here, we've got another inscribed angle, but this time we don't know how big the angle is. So what we're going to need to do is take this 47 and divide it by 2 in order to figure out how big angle D is. If you divide 47 by 2, you'd get 23.5 degrees for angle D. All right, here's just a few more pictures. Any of these pictures that we see that's got a point C labeled, we're going to assume that C is the center of the circle. So we're just going to see if we can figure out how big any of these angles and arcs are. Might be a good idea right now for you to pause the video and see if you can try some of these pictures yourself and then check your answers when you're finished. So I'll let you pause the video and give those problems a try. All right, let's check and see if you got them right. So I would think about whether or not you've got central angles or inscribed angles. Angle A, or the angle in picture A, I should say, is an example of an inscribed angle. So you're going to want to do 118 and divide by 2 to get your answer for that. X should be 59 degrees. B is another example of an inscribed angle. This time I'm trying to figure out the arc, so instead I'm going to double it. So 41 doubled would be 82 degrees for the size of this arc right here. If you look at C, we've got 3 different things to figure out, starting with X. X right here is this arc that goes halfway around the circle. I can see that this other line here is a diameter of the circle, which means that the arc going around there for X is going to be halfway around the circle, which is 180 degrees. Y and Z combined together are going to be 180 degrees, but what we're going to want to do for this is use this 78-degree angle. This 78-degree angle is an example of an inscribed angle. So if this angle right here is 78, you'd want to double that in order to figure out what Y is. In this case, Y would be 156 degrees. Then to figure out what Z is, Z and Y combined together are going to be 180 because they go halfway around the circle. So an option to figure out Z would be to take 180, subtract 156, and you get 24 degrees. If we go on to the next picture, we've got this 56-degree angle here. That's a central angle since it's got its vertex here at C. Central angles and their arcs are the exact same size, so that means X is going to be 56. If you notice Y is an inscribed angle, you can see that we're going to take 56 and divide it by 2 to figure out what Y is. So Y would be 28 degrees. If we go to our next picture, we've got this central angle again here. So this angle right here is a central angle. That's what we're trying to figure out for X. That's going to match how big its arc is. So X is going to be equal to 114 degrees. And then y is an example of an inscribed angle. So y has its endpoints on the circle, which means you're going to take 114 and you're going to divide it by 2 to figure out what y is. In this case, it's 57. And then our final problem here, we've got an example of an inscribed angle that's 28 degrees. In order to get the arc, we're going to double it. So if you double 28, you get 56 degrees. That's how big x is. And then the last question here is for y. Y is an example of an inscribed angle again. If you know your arc is 56, you're going to divide that by 2 in order to figure out y. So y is 28 degrees. I've got 2 tasks that I'd like you to do in class today. The first is to work on a half sheet. So if you've got a substitute teacher today, your substitute should give you copies of that half sheet. I'd like you to do your best trying to figure out the central and inscribed angles on that half sheet. And you can turn that into your sub. The final task for today is to work on your Canvas assignment, which is all about central and inscribed angles. Hope you have a great day.